Welcome, everybody. Thank you for having me at the Velodyne booth. My name is Amir Ruben. I am the president of Paracosm. We are a small technology company that based in Gainesville, Florida, and in 2017 we were acquired by San Francisco-based Occipital, who is one of the leading companies in spatial computing and 3D sensing. They are the makers of the structure sensor 3D camera. And what we do at Paracosm is we develop a handheld 3D mapping system built around Velodyne's VLP16. And what I'm here to talk to you about today is all the really cool stuff we do and that our customers do with our fancy device you see there that does not involve self-driving cars. So we're in the middle of this section of CES where there's self-driving cars of every shape and size, fully equipped with Velodyne Lidars and autonomous driving capabilities. But I'm here to tell you that there are some really industry-changing applications out there that are being done with this same technology that has nothing at all to do with autonomy or driving. So without further ado, let's dive right in. And so at Paracosm, we like to think of ourselves as the leader of handheld LiDAR mapping. And so our flagship product is PX80, the Paracosm Extreme. It's PX80. And what this is it's a completely integrated unit that has a wide-angle camera on it, the Velodyne VLP16, and high-grade XSENS inertial measurement units, accelerometer, gyroscope, and all of these sensors are all built into the device. The device has a built-in hard drive, Intel processor, battery system, and what happens on our device is our proprietary SLAM engine, and I'll explain what that means in a minute, combines the data from all of these sensors to, keep cutting out here, combines data from all of these sensors to calculate the user's position as you walk with our unit. So what SLAM stands for is simultaneous localization and mapping. And so that's exactly what our system does, is we enable our users to map an environment without the need for GPS and without the need for any other external system. And so the way laser surveying and laser scanning and mapping is done today is with these tripod-based systems that collect data from a static position. And you can see in a top-down view of a typical work site, you would have to drop a tripod in like dozens of places to fully cover an area with your laser data. And so what's really exciting about SLAM-based laser scanning is we break free from the constraints of a static tripod position, and just like a self-driving car just drives down the road, we let PX80 users just walk through a site without having to set it up, without having to sit down tripod positions. And what this does is it lets them walk through a work site, walk through a factory, walk through a forest 16 times, 20 times even faster than traditional. And what this does is it opens up entirely new applications for LiDAR mapping. Because now, for the first time, people are able to have a constantly up-to-date 3D scan of their environment. So by making scanning really fast, easy, and accessible, we allow architects, engineers, surveyors, construction workers, people in forestry management to pick up a handheld device, walk it through their site, and have an instant 3D copy of their environment that they can use to manage their environment, their facility, whatever they need to do. And because it's so fast and easy to do, they are always able to have an up-to-date model. So this opens up many new use cases that have not been really possible before. All right, so enough intro talk. Let's dive into how people are actually using the PX80 in their day-to-day operations. So this is a chilled water plant, industrial environment with a ton of complexity, a whole lot of pipes, and there's a lot of factors that need to happen when you're managing an industrial plant like this. You need to know where all your pipes are, you need to know where all your equipment is, you need to be able to plan for new equipment, your industrial processes, all your new electrical and plumbing, and the way this is now able to be done is by walking around with the PX80 to capture an exact replica of both the interior and exterior of your environment in full color, capturing all of the details for the first time ever, from the parking lot, your cars, the exterior of your building, to the actual water processing tanks, the plumbing, not just on the exterior of the plant, but we can actually zoom in through the doors here and now have access to the entire interior, even down to the stairways, the pipe trees, the valves. And so now when a question needs to be answered about your facility, such as, can this new piece of equipment fit, or do we need to plan out a new process or do any sort of construction or renovation, you have an exact up-to-date digital twin where you know what every single pipe, valve, electrical box, and piece of equipment in your factory is in the exact current condition, in full color to a 2 to 3 centimeter metric accuracy. So these are enabling PX80 customers to have unprecedented insight into the actual condition of their facility without having to rely on moldy printout blueprints that are 10 years old and way out of date and unreliable, untrustworthy. This is another example of how people are using LiDARs in the real world. This is from SGDL engineering in Peru, and they take the PX80 out to the stockpile yards to measure the volumes to a very high degree accuracy of their gravel or whatever construction material they have. And with a quick walk, they're able to now know exactly how much material is in their stockpile and if they have enough to complete their job, if they need more. Another PX80 customer, NMCN, based in London, uses the PX80 for many uses, among them to monitor their very complex construction projects. Now, because the PX80 is capable of scanning both interior and exterior spaces, whether you're in total darkness or complete sunlight, we can capture these very complex construction sites. You can even see a few people standing in the way there with all these steel beams and structures and pillars and columns. We're able to let NMCN is now walking these construction sites and capturing the condition of the site to make sure everything is happening to the right degree of quality. They can measure the position of every steel beam in comparison to the construction plans and ensure that the construction project is done correctly and on time and that you're not having any sort of mistakes. Another example of a construction site. So one of the huge problems construction faces is if a small error is made and you keep building on top of a wall or pillar being 1 foot off or a wall being slightly out of plumb, and you keep building your skyrise on top of that, if you discover the error too late, you have to tear down all that work, and that completely destroys your project schedule. So with PX80's SLAM-based scanning, people are able to walk through the construction site and always have an up-to-date picture of the exact condition of the site. And they're able to know exactly where all of the steel beams and the pipes are. They're able to see the position of every column, every installed pipe, and they can measure that to the construction plan to know that they're on schedule and everything is being built correctly. So again, this is a revolution in managing cost and schedule on construction, which is an industry that is notorious for going over budget, over schedule. So big game changer for the construction world. And you can see the detail we capture, you can differentiate even between cinder block and steel structure with the VLP's LiDAR data and the PX80's color camera. Another interesting use case, again, from NMCN in our partners in London, is for factory and warehouse management. So many factory and production floors have material moving everywhere. They have people moving everywhere. They have shelving systems and racks and equipment all over these huge facilities. And the question is always, how do we plan material moving through our factory, through our facility? How do we know what's going on in our storage shelves and our units? And so the PX80 is able to collect an exact snapshot with high metric accuracy in full color of this factory warehouse type facility. And you can see here, oh, I have my steel beams here. Well, you can see a ladder right there. You can see exactly what's going on your factory floor. You can even see we capture the workers in their vests mid snapshot. And you're able to import all this data into your planning tools so that you know what material is on your shelves, how you have to move things and improve your planning through the factory floor. And because the PX80 allows you to walk the Velodyne VLP right through your facility floor, this whole capture only takes a matter of minutes. It's under an hour of total time to get this data. So you're always having an up-to-date, real-time picture of your complex operations that now your planning can reach new levels of efficiency. And not shown here, but in addition to your 3D data, we also capture the images from the camera. And I'll show some example of imagery overlaid onto the 3D data in just a bit. But now you're also able to zoom in and dive in with imageries, which we'll show some examples of later. So what's interesting also is with the Velodyne VLP's capability and the Paracosm's PX80 scanner to scan both indoors and outdoors, we're also able to scan street level views here. And this is Port St. Joe in Florida. They were hit hard by one of our recent storms down Florida. And so the local city did a quick scan of this city street with the PX80, and you can see we capture utility poles, stop signs, and just the general condition of the houses and street. And now this data is going to be used for urban planning to make sure, like, do I need to move any utilities around, or do I need to do any restoration or repairs on any of these houses? So all the data you need now to make decisions and planning, from the house renovations to the street signage to the utilities themselves, is completely captured with just a quick walk or hold the PX80 out your car window and just drive it down the street. And we capture everything you need to be able to fully do both city planning, utility planning, and storm restoration. Another example from a PX80 partner, Wiso, based in Norway. So they're way up north. It's cold this time of year, so we'll see a little snow. But this is also a local municipal government project of trying to capture this small neighborhood in Norway so that they can do more development planning around this neighborhood for the building. They want to capture the street condition, the building condition, and you can see we have the Norwegian sunset, we have the snow on the ground. PX80 works no problem in harsh weather conditions, and we're able to get all the information we need to make sure that the building dimensions are correct, the street dimensions are correct, the utilities and street signage look good, and that we can now do our planning around this pretty complex environment with a lot of nooks and crannies that with normal methods would be really hard to capture this level of detail to this degree of accuracy in full color. You can imagine the challenges of doing this with a traditional system like a tripod would be, this would take days, maybe even weeks to capture with a tripod. Or if you were to use a GPS-based mapping system, GPS is not very accurate when there's narrow buildings, corridors, or indoors. The GPS signal bounces everywhere. So what's really exciting about Paracosm's PX80 SLAM engine is it enables our users to capture an environment just by walking or driving slowly through the environment, and we don't rely on GPS signals, we don't need to be in a static position, and we're able to capture everything from the parking lot to the inside of the buildings in a wide variety of conditions. Sometimes people have more mundane use cases. This is a kind of an office type environment, a college campus, and here this is a simple space management exercise of the facility management at this university needed to know the square footage of this building on campus. They needed to know how the space was being used in the administration side. They want to look what's going on in their classrooms, in their cubicles. So they basically just need a complete picture to know what's going on in my facility. How is my space in my facility being allocated? What percent is being used for office administration? What's going on in my cafeteria here? What's going on in my lecture halls, my classrooms, and all the way down to the kitchen infrastructure. And so what's really powerful is one device in a matter of minutes and walking through a complex facility is able to answer all of these questions just by a simple walkthrough. And now the facility management software is able to model everything from the plumbing to the floor planning of a building like this. And I'll show some examples in a minute of facility management partners that Paracosm works with that import the raw PX80 scans that you see here into facility management software to enable more complex and more interesting high-level workflows. But again, what's really exciting is the ability to actually see every doorway, every exit sign, every complex mechanical structure in your building with just a handheld device, and capturing it in the time it takes to walk through is unprecedented. So here's an example of how people might use the raw data. So you might have noticed a lot of this data is coming off of the LiDAR, and you can see the Velodyne Lidar is shooting out laser points, and so we colorize those points from the camera on the PX80. So the end result of the scans that I've been showing you are a bunch of colorized laser points. That's called a point cloud. So what you see here is the raw results of the scan. You can see they're individual points, which are each representing a LiDAR beam that's taken a measurement. They're in color from our camera. And people want to create nice, simplified models so that they can use these models for easier access planning. So a very common use case is people will take these raw point cloud scans from the PX80, dump it into an Autodesk tool. It's a very standard, industry standard tool, and they model on top of it. They basically trace actual bricks, actual walls on top of the points, and they create these beautiful models that you'll see here in a minute. And all of a sudden, we have a building model and not just a raw scan. So this process is called building modeling, and the end result is a building information model. And with the PX80, one thing our users are very excited about is the ability to create, to capture the data and create building models in record time. And they find that they're getting more accuracy sometimes than with traditional methods because they're able to walk around and capture all the details that they need. So here's a building model of a really complex building, like a multi-story high-rise. And one of our partners and customers, AkitaBox, makes a facility management software package that imports all this complex data for facility managers to be able to make their facility planning decisions, repair schedules, asset tracking. A lot of these buildings have a lot of important assets. Maybe that's an asset could be anything from office equipment to a fire extinguisher to whatever you care about in your building. And so in this case, they created a 3D floor plan from the PX80 scan, and then they wanted to track in high detail the MEP room, the mechanical, electrical, plumbing infrastructure of the building. So they captured a full scan of the building, they model it into a simplified 3D floor plan, and then what you see here is this is a healthcare facility in Florida, actually, and the HVAC system, the plumbing system, and the water systems of healthcare facilities are very mission critical, so they want to keep all of the detail that they can intact so that whenever they need to do a repair or know what's going on with their building's mechanical, electrical, plumbing infrastructure, they can make the informed decision. So the PX80 allows them to have a true, as-built, up-to-date, accurate snapshot of all this critical building infrastructure. And again, they're not relying on finding 20-year-old blueprints dusted off the bottom shelf of someone's old desk and it's all moldy and coffee spilled on it and you don't trust it, it's not reliable. This is an up-to-date, accurate picture of what's going on with full 3D measurements. And then, as I mentioned earlier, you're able to take all of this complex data and boil it down to a nice, simplified top-down view and use it as a blueprint to overlay high-resolution 360 imagery so that you can now virtually visit all the locations that you scanned in your facility and actually get a high-resolution imagery snapshot. So in this case, you're viewing a 360 panoramic image to see what's actually going on during the renovation construction of this part of the facility, or in this case, the infrastructure, space with all your ductwork and pipework, and you're able to use the PX80 scan data as the skeleton infrastructure to know what's going on, to take actual measurements, but also as a way to organize your imagery and 3D 360 photographs. All right, so some other cool stuff people are doing is in one of our customers and partners in Japan, Woodinfo, have a little video hiccup, uses the PX80 for forestry management in the mountainous forests of Japan. And so what they do is they mount the PX80 to a backpack and they go for a walk through the forests of Japan, and they call their system the Forest Walker. And what's really nice about this visualization our great partners Woodinfo put together is it really shows the PX80 in action. You can see on this screen the pink dots are the walking path of the PX80 operator, and as you walk through the forest, the LiDAR sweeps, the LiDAR data from the Velodyne fill in, and you can see each point is colorized from our camera, and we construct step by step the forest, the digital forest. And the end result of walking through the forest is a 3D map, 3D digital replica of this forest. Now, this is a pretty simple park, but they actually go hiking through some pretty mountainous terrain, and the PX80 is able to walk up and down even steep elevations because we're not bound to a tripod. We're able to walk under tree canopy because we're not reliant on GPS. So the PX80 and with the help of Velodyne's Lidar, is able to completely grab all the information we need about the tree's location, the tree sizes, the tree circumference. And this is actually solving really important problems in Japan, that they have a lot of trees on very steep mountain slopes. And when a tree is weak and it erodes, if the ground surface looks weak, if the tree is too skinny, when a bad storm comes through, the tree is going to collapse, flow down the steep mountain, and cause flooding and erosion and possibly disasters, which has happened several times in the past. So now what they do is they hike these forests, many of them very steep, and they analyze through their walking route every tree that's at risk of being, eroded and washed away by a flood or a storm and cause damage, and they're able to look at the topography of the land, the health of the trees, the condition of the ground, and calculate what trees need to be removed to make sure that there's enough buffer to prevent a disaster from tree erosions due to either natural erosion or a storm coming through. So the PX80 mounted on a backpack here is versatile enough to do everything from constructions to factories to warehouses to disaster prevention in the forests of Japan. I'm just going to end on some cool other side use cases. This is the GeoNav group based out of New England, and this is actually this is a forest, but the application here was not to monitor the forest. They were going into the heart of this forest for a historical preservation project. There's actually an indigenous wall in the middle of this forest that they wanted to preserve. And if you can see, for historical purposes, there's a small wall right in the middle there that, let's see if we'll get a better shot in a minute. Oop, maybe not, I'll show the next slide. Same area, but there's a small cave. You can see we're looking underground. There's actually a cave hidden underground here. So we're looking at it from the bottom up, and we've scanned the forest, and then we can zoom in, and there's a secret little cave that is perfectly preserved and captured in 3D for historic preservation and archaeology purposes. And we can virtually sneak in and visit this, 1,000-year-old cave. All right, last fun little example we have here is Intech, one of our partners in Malaysia, scanning a large cavern in Borneo. And I don't even know where this would be on a map. But you can see when we zoom out of the scan, it's a completely enclosed underground cavern with a whole walkway system, probably a little bit of ecotourism going on in this cave. And the local government wanted this captured for, again, planning purposes, to make sure that they can do all the renovations, because you can see it's a pretty complex series of walkways and infrastructure to both preserve the ecology of the cave and make sure it's accessible to tourists who are visiting. And it's a pretty striking scan to see bio cavern. And so that's all I have to show for today. If this was interesting to you, please visit our website, enter your email, and we'll send you a bunch of educational information about 3D mapping and learning more about point clouds and SLAM engines. And if you have any applications you need help with, we'd love to help you out. And otherwise, any questions or discussions, just raise your hand.